Welcome back to day 14, session 2. Professor Rajeeth is going to present the topic on steel structures related to GATE to 2021. Professor Rajeeth T J is working as assistant professor in the Department of Civil Engineering, Vidyardhaka College of Engineering. He received his Bachelor of Engineering and MTech degree from SJC Mysuru. He has 6 years of experience in teaching and research. His area of interest is in steel structure, fatigue analysis, and so on. So, I would like to hand over the session to Professor Rajeeth T J.
Thank you, Professor Manoj. So, welcome all the GATE aspirants to this session on steel structures. I first of all thank my beloved HOD Dr. S.K. Prasad and coordinator Dr. P.K. Umesha for giving me this opportunity to share my knowledge regarding steel structures pertaining to GATE 2021. So if you go for presentation, so this is what the subject we're discussing today. So if you analyze the GATE question paper, okay, in the previous years, here if you observe in 2020, we got 1 mark, 2 mark question, 1 question. So whereas in set paper 2, we got 2 marks, 1 question, 3 marks, 1 question. In 19 again same thing. In 2018 we got 2 mark of 2 questions and 1 mark question. Total 5 mark we got here. So on another if you observe, so from 2014 to 2020, so we may expect 2 to 5 marks from design of a steel structure for your GATE examination. Okay, if you go to the syllabus, so we have working stress and limit state design concept in our GATE syllabus, and design of tension and compression members, beams, beam column, column bases. So connections here we have simple and eccentric connection, beam column connection, plate girders and trusses, and concept of plastic analysis related to beams and frames. The thing here is today we are going to discuss only, so if you observe the previous year GATE questions, so many questions we are going to ask from the connection part and also from the plastic analysis. So today we are going to concentrate on limit state design concept and also the connection part with respect to bolt and welded connection, considering both simple and eccentric connections and beam column connection. So remaining portions I will discuss on next session on steel structures. Okay, so next, so this what a picture shows the hard rolled steel sections, so consisting of 5 section, channel section, and angle sections. And with respect to this subject, we need to refer the code book IS 800-2007. So that is with respect to limit state design of steel structures, where I have taken some of the tables, important tables in terms of the important points, so pertaining to your GATE examination. So here I have taken what your physical properties of steel structures according to the code. So this is given in class 2.4.1. So unit mass of steel is 7850 kg per meter cube. You should remember all these values. These are all basic values you should remember as a steel material. And also the exponentials of steel is 2 into 10 power 5 Newton per millimeter square, Poisson ratio 0.30. So modulus of rigidity 0.769 in 10 power 5. Coefficient of thermal expansion for steel elements is 12 into 10 power minus 6 per degree centigrade. Okay. So if you go to the next information, so here we should know some of the information with respect to the loads what we need to consider for our steel structures design. So first load is what dead load. So this one we need to consider or we need to calculate according to the code IS 875 part 1. So by considering unit weight of the material what we're going to use in our construction purpose. So this we call it a dead loads, we also call it as gravity loads. So which are all always act vertically downward. So these loads are relatively constant over a time. So therefore these loads also called as permanent loads. So next is imposed loads or live loads. It may change with respect to time, in position and also in magnitude. So therefore these we call it as temporary loads, not permanent loads. So these things we need to calculate according to IS 875 part 2. So when come to wind loads, if our buildings are more than 10-meter height, then we need to consider a wind effect on that building. So normally steel structures are made up, so preferably we'll construct for industrial buildings where those buildings will be more than 10-meter height. So in that situation, we should calculate, or we should take the effect of wind loads on the industrial building. That one we need to calculate according to IS 875 part 3. So next is earthquake load. So we all know that due to the ground motion of earthquake, it will causes vibration on the structure. So we're going to get this vibration that are shake in all three directions. So this one we can calculate if the earthquake prone regions where we are designing the building. So this is according to IS 1893 part 1. Next is erection load. So in case of steel structures, erection load are very, very important. Why? Because we are doing so many operations. So welding operation, bolting operation, drilling operations on the steel structure itself to erect. So one more steel structure. So one more element to the other element. Therefore, the erection load we need to consider carefully, particularly in case of steel structures according to IS 800. That is class 3.3. So next is accidental loads. This is due to the blast and impact load of vehicles. So we need to consider if it is required. So next is the notional loads. These are the loads it will arise due to geometric imperfections. So this is the load we need to consider for all the load combinations. So many people will neglect this load. So since the geometric imperfections will cause differences, stresses in the materials. So while the structure is functioning, so therefore we need to consider carefully these notional loads, and also secondary load effect, which is resulting from temperature changes, differential settlements, eccentric connection, rigidity of joint, etc. So next, if we come to load combinations according to the IS 800 2007. So we need to take here. I have highlighted the crane load here. So why? Because the crane load which is resting on the steel structures will go to erect one more element or one more floor. So where we need to consider the structure you're going to erect using the cranes, we need to consider the crane loads effectively. So therefore, according to the code, they are given separate section here. The one load combination, dead load plus imposed or live load plus crane load. So other second one combination is dead load plus imposed load and crane load and wind or earthquake load. If you observe here, so the effect of wind and earthquake will not supposed to consider simultaneously. So they will not act simultaneously. Therefore, so if you take that will use a more load combination, load value. So it will lead to uneconomical design. So therefore, while considering wind and earthquake, we should consider any one at a time. So similarly, in the fourth combination, dead load plus wind load or earthquake load. So last one, I have told that the erection load is the main important criteria in steel structures. We should consider erection load also with dead load. These are the four basic combinations. So again, it depends on the engineer who is involved in the construction of a steel structure. So we will going to decide what the load combination must be, he has to consider. So next, if you go for limit state design, so the acceptance limit for any safety and serviceability requirement of any structural element, that we call limit state. So according to the code, so always we need to satisfy this equation, design action. So what is the design action? Is nothing but the design load must be what less than or what your design resistance, nothing but design strength of the material. Okay, that is what the thing we need to observe. So here we can classify limit state in two categories: limit state of strength and limit state of serviceability. So we'll see in detail now. Limit state of strength includes, according to the code, these are some of the points you should know, because last year I observed in IS paper they asked this question. So here you should know what are the things which will come under limit state of strength and limit state of serviceability. You should know that. So after discussing the theory portion, we will go to review some important questions. So after completing the theory portion here, so loss of equilibrium of structure, this will come under limit state of strength. Loss of strength of structure, that will also come under limit state of strength. So failure of excessive deformation, rupture of structure. So the part or any component of the structure if fails, that is also come under limit state of strength. Then fracture to fatigue and brittle fracture. So these are all the things will come under limit state of strength. If you look into limit state of serviceability, so it is respect to the when the structure is in usage. So we need to check this serviceability criteria. Okay, here where this includes what the deformations or deflections, so which may adversely affect what appearance of the structure, and the vibrations on the structure, the repairable damage, the crack due to fatigue, the corrosion, durability, and fire. So these are all the criteria will come under serviceability, limit state of serviceability. Now we will see. So one review question on this concept. So can you answer for this? Which of the following is not the limit state of strength? So option A is fracture due to fatigue, brittle fracture, rupture of the structure, and vibration structures. So answer is vibration structure, because if you observe the last slide, so limit state of strength includes what? Loss of equilibrium, stability of the structure, rupture of the structure, fracture due to fatigue, and brittle fracture. Whereas your vibration will come under limit state of serviceability. Okay, so that is where the answer here is. The answer is the vibration of the structure will not come into limit state of strength, it will come in limit state of serviceability. So therefore you should know what are the basics, the criteria we should consider as a limit state of strength and limit state of serviceability. So with respect to your GATE examination. So next, if you go for design actions, so according to the code, see here we have the formula that design action equal to QD equal to summation of gamma FK and QCK, where QCK is the characteristic load and gamma is the partial safety factor. So exclusively for loads, gamma F in case of limit state. So it is given in table number 4. Okay. So what is gamma F? Take care about. So there may be a possibility of unfavorable deviation calculation. So deviation load calculation in assessment of load accurately. So those things we can take into consideration by while taking the partial safety factor. But according to the code, so they given separately table number 4 exclusively partial safety factor for loads, that too exclusively for limit states. So that is limit state of strength and limit state of serviceability. Here limit state of strength they are given for load combinations here. So I have told in the last slide that various load combinations. If I observe here, dead load, live load, and crane load is one load combination. Okay. So the next one is dead load, live load, crane load plus wind load or earthquake load. So next load combination, dead load plus wind load or earthquake load. You should remember this, dead load and direction load. Okay. Here if you go for partial safety factors, so here for dead load, almost for all the two here almost all the loads combinations of gamma factors are more than 1. So that is 1.5 for first case, again 1.5. Okay, this is for what your dead load. So for first combination, dead for live loaders is 1.5. Like that, I think you should remember minimum of, for these basic combinations you should remember these values. So 1.5 and 1.5. So this leading load always will consider for live load. Okay, wind load is not given here since we are not consideration into account while considering the combination. Dead load we should give 1.0, again 1.0 here. So for GATE examination, so you should remember this basics partial safety factor for load, since we have used these things while calculating the load combination and while designing your elements design for still such a subject. Okay. So here we will see one review question on this. For combination of dead load and earthquake load, the partial safety factors for limit state of strength are respectively. Here the 1 marks question. So partial safety factors. So we need to select appropriate partial safety factor for combination of dead load plus earthquake load. Here if you observe for dead load plus earthquake load here, so partial safety factor here is so dead load plus earthquake load here you should go for this. So 1.2 and 1.2. If you observe here, 1.2 and 1.2 is the correct answer. So you should remember that value. Okay. For dead load plus earthquake load combination, the limit state of strength is 1.2 and 1.2. Similarly, they may ask any load combinations, and you should know the partial safety factors for respective load combinations. Okay. So we'll move on to the next slide. So design strength. So design strength here is, what is design strength? That is design strength equal to the ultimate strength divided by partial safety factor. Okay, ultimate strength divided by partial safety factor for material. So why we need to consider this partial safety factor? This will consider what the geometric imperfections, the material strength, the uncertainty in calculating the strength of the material. All these things will going to take care about by partial safety factor for material, that is gamma m. So in code book, gamma m is separately given, table number 5. So this is very, very important table. You should remember all these values for all these criteria. Okay, you should remember the partial safety factor. Okay, since we have used it in all the designs, so many of you remember this value. So they will going to give some of these values directly in the problem. Otherwise, you should assume. So directly they will give the condition. According to that, you should assume. If you see in detail here, so partial safety factor for the resistance governed by the yielding, that is gamma m naught, is 1.10. Partial safety factor for resistance of buckling is gamma m0, again 1.10 for buckling. This for yielding. First case is for yielding. If you go for third case, governing by ultimate stress gamma m1, which is 1.25. Okay. So similarly here, if you go for connection part, resistance to connection. So here we have two categories: shop fabrication and field fabrication. If you go for shop fabrication, gamma mf for bolts of friction type, then you should take 1.25, both shop and field fabrication. If it is bearing type of bolts, then you should take 1.25 again. Then if it's rivets type, it's going to take 1.25. Whereas in case of welding, so this is one more interesting, the partial safety factor for weld. If you do it, shop, you need to take less partial safety factor since we have more control over the welding process. And if you go for field welding, okay, you should take 1.50 as you don't have any more control compared to the shop fabrication. Therefore, we need to choose 1.50 for field welds. Okay, now, so we'll see one question on partial safety factor for material. The partial safety factor for materials governed by buckling is option A 1.0, option B 1.10, option C 1.15, and option D 1.25. So if you see the table number 5 for buckling, so partial safety factor is 1.10. So it's a 1 marks question. So you should know all these partial safety factors. They may act directly. So whereas in the case of problems, they may give for welding, they will give the condition: shop fabrication weld or field fabrication weld. For numerical problem, they will give. Otherwise, so you should remember these values. They will ask directly for 1 mark question, the partial safety factor. So if you go for deflection, so deflection, another one criteria in case of steel structures, it is given in table number 6. Here they are given as two categories here for industrial buildings. So vertical load and lateral load. Here you should remember this. In some of the important things here, you can remember a gantry girder. So manually operated crane, so span by 500 is the limit. So electrically operated up to 50 ton crane, that is gantry crane, can go for a span by 750. So again for gantry crane, you can span by 1000. So and also you can remember starting 4 values: live load by wind load, purlins and purlins. You should assume span by 150, span by 180. So they may ask this question, so repeated. They will ask in IAS question. So in the similar way, they may ask in GATE also in future. So you should remember this. So one time they asked on gantry girder the limitation, deflection limitation they asked. You should remember span by 500, span by 750, and span by 1000. Okay. If you move on to the next slide, so we will go for the connections now. Okay, design aspects of connection. So normally we will prefer in case of steel structures, okay, 2 types of connection: bolted connection or welded connections. So we will see in detail today the concentric bolted connection and eccentric, that is bracket connections, the problems. So connection, if you want to study this steel structure subject, you should be familiar with the connection part. So that is bolted and welded connection. If you observe in the last question paper, they are repeatedly asking the same type of questions. We're going to discuss now in the next slide. So please concentrate more on your bolted connection and welded connection part. So now we'll go for first the bolted connection. And I have taken what type of bolts here. So we are first picture shows is this one. The left hand side is what your ordinary bolts. Okay. Whereas the second one shows HSFC bolts. So this is what the shank portion. This is what thread portion. So we'll go to use this property while calculating the bearing strength of the bolt. So this were the types of bolts. So if you go to the tensile properties of the bolts, so normally bolts will go to categorize into different grades 4.6, 4.8, 5.6, 5.8. So here they ask what is stands for 4, what is stands for 6. Okay, the explanation. For that here is their explanation. So for example, if you take 4.6 grade means, okay, the first letter indicates, the first numeric indicates the ultimate strength in the material. So for example, if you're using 4.6 grade bolts means you're using for bolt, ultimate strength of the bolt material is 400 Newton per millimeter square. Okay, that is 4 indicates 1 by 100 the nominal ultimate strength in Newton per millimeter square. And this second letter 6 indicates, number 6, the ratio of yield stress to the ultimate stress. So ultimate stress is 400, whereas yield stress is 240 for that material. The ratio of 400 by 240 will give your second letter, that is 6. So here you should know that is 4.6 grade bolts. We are going to use 4.8 and 5.6. So you should know what is that 4 indicates and first letter and second letter. So they may ask in the examination. Okay, the different grades. So if you go to the next slide, so types of bolted joints here. Okay, types of bolted joints. Here we have single bolted lap joint in the first figure, single bolted lap joint, double bolted lap joint. So lap joint means we should keep 2 plates one above the other. Where they use this, what your cross-sectional view, we're going to see only one bolt in the middle here. Whereas here they have used what 3 number of bolts to connect 2 plates one by placing one over other. In a similar way, double cover butt joint. Okay, lap joint here they have used here. Okay, here there is what 6 numbers. So this what with respect to lap joint. If you go to butt joint, we need to place one plate adjacent to one place adjacent to other, and we should use one cover plate in case of butt joint. Whereas in case of lap joint, we're not supposed to use the cover plate. So we should use what the cover plate in case of butt joint. Okay. So here this is what the first figure shows, the single cover, single bolted butt joint. The second figure shows a double cover, double bolted butt joint. Okay, this is what double cover, double bolted butt joint. The next thing here is, so they will give the question like this. So they will give these 4, what is this? The figures or the connections, the design details like single bolted lap joint, double bolted lap joint, single cover, single bolted butt joint, double cover, double bolted butt joint. So in this, all these 4, which of the section, which of the connection is free from eccentricity? So eccentricity while transferring the load. So for example, if you take the lap joint, so from this lap joint, okay, from this lap joint, okay, from this plate, it has to transfer through the board, it has to transfer to this. The load has to transfer through the connection to the other member. So here while transferring here, okay, if you take this, okay, element, so while transferring, the line of action of this force, this plate and above plate and bottom plate are at a distance, that we call it as eccentricity. So therefore this connection will produce eccentricity. If you go for double bolted butt joint, lap joint also produce eccentricity. Whereas if you go for single cover, single bolted butt joint, so this will not produce eccentricity. Okay, so this will also produce eccentricity. Why? Because this load will transfer to the cover plate, again it will transfer to the joints. Like this, it will also produce eccentricity. Whereas this butt joint, it will not produce eccentricity because that load will directly transfer to the place to plates. Okay, so butt joint will results in 0 eccentricity, whereas lap joint will result in the eccentricity. So that's what the concept you should know from different types of bolted joints. So if you go to the next slide, so you should know the various failure types of the bolted connections. Okay, here if normally our bolted connection will fail by shear failure of bolt. Okay, due to the less strength of the shear strength of the bolt after the application of the load, the bolt will fail by shear, and also the bolt may fail by bearing, and tensile failure of bolts may occur, that is particularly all three with respect to the bolts. So, and you should know the behavior. So all these formulas given in the code book, but I will discuss the problem, then you'll come to know how to remember those formulas. So next is what your bearing strength of the plates and tensile strength of the failure of the plates will happen because of less tensile strength of the plate when compared to the bolts. So otherwise, so another one failure is black shear failure. So this figure shows the bearing failure of the plate, okay, the tension failure of the plate, and the black shear failure of the entire the joint. So this is what the failure of the bolted joints. So here the black shear failure will have, you know, the most critical one. So shear and bearing are the most common one. If you provide sufficient edge and pitch distance, so we can avoid tension failure of plates and all. Okay, this what about failure of bolted joints. Okay, so next thing is the clearance or holes of fasteners. To give any bolts, we should provide extra clearance to the bolts, so that we correct as diameter of the bolt hole. Okay, standard clearance diameter bolt hole we should give to connect the bolts. Here you should remember this value. Table 19 is given, okay, in the code book. So you should remember this value at least. Okay, sometimes they will give. If they're not given, you should remember this. For 12 mm to 14 mm diameter of bolt, you should give 1 mm diameter extra. For 16 to 22 mm, you should give 2 mm extra. That is about 24, you should give 3. For 24, you should give 2. So this one, at least you should know how much extra clearance you should give for your bolt. Okay, the clearances for bolt holes to connect the bolts. Okay, so here then we'll go for some important specifications what they mentioned in the code book. These are things you might have used in designing your bolted connection, calculating your bolt value and all. So some of the important points you should remember here. The minimum spacing. The minimum spacing of the bolts, nothing but pitch of the bolts. That is, so if you have a connection here, distance between two consecutive bolts. Okay, so along the direction of the load, we call it as pitch. So how much pitch we should provide between the bolts? So why we need to provide this? To give sufficient space to tighten the bolts while erecting the structure. Okay, to give that, we should provide the minimum spacing here. The distance between center of fasteners, nothing but bolts, shall not be less than 2.5 times of the nominal diameter of the fastener. So assume that if you're connecting with 20 mm diameter bolt, then what is the minimum pitch we supposed to provide? P minimum according to the code. So many times they asked it in IAS question this one. So you should remember this value, 2.5 times of the nominal diameter of the bolt. So for instance, if you take 20 mm dia bolts, okay, 20 mm dia bolt, then how much pitch you supposed to provide for 20 mm dia? 2.5 into 20. So that much you should provide as a minimum pitch. So that is what your pitch. The maximum limit also is clearly given in the code book, the distance between the two bolts here. So maximum clearance is given. So this should not exceed 32 times of T or 300 mm, whichever is less. So in general, so if you pertaining to tension members, if you're using the bolts, the maximum spacing should not exceed what? 16 times of the T or 200 mm, whichever is less. For compression member, the value is 12 times of the T and 200 mm. You should remember this value. Why? Because they're going to ask frequently this value in IAS and other competitive examination. So here T indicates your what? The thickness of the thinner plate. So if we're connecting two plates, the thickness of the thinner plate you should consider while calculating 32 times of T, 16 times of T and 12 times of T. Okay, this is what the thing with respect to what your so maximum and minimum pitch, nothing but maximums and minimum spacing according to the code, where minimum spacing is 2.5 times of the diameter of the bolt, while maximum spacing is, it will be different for different types of members. You should remember this well. Then if you go for minimum and maximum edge distances. So why should give minimum and maximum edge distances? So to avoid tension failure to avoid bearing failure, to avoid moisture problem. So if you provide more, the edge distance, end distance, there will be a problem. Minimum edge and end distance, and maximum edge and end distance. So according to the code, you should also remember this value. According to the code, the value should not be less than, that is E minimum, we correct as E minimum should not be less than 1.7 times the whole diameter. Here if you observe here, in case of page, we have taken P minimum, we have taken 2.5 times of the D. Whereas in case of pitch edge distance, you should take 1.7 times of the whole diameter. That is, I should consider what 1.7 times into D naught, where D naught equal to nominal diameter plus nominal diameter plus what your the clearance, what we discussed in table number 19 given in the code, that is what your D naught. So nominal diameter of the board plus clearance, what you will going to give according to the board diameter according to the code. So this is 1.7 times. If you observe here, 1.7 for sheared or iron frame cut edges, the minimum edge distance will be 1.5 times for machine flame cut or plain edges. So this is what your 1.5 times for E minimum and 1.7 times. You should remember this value. So sometimes if they're not given anything, you can assume your as 1.7 or 1.5 your wish. If they given about the information about the cut edges and flame cut edges, the how they cutted the material. So based on that, you can decide whether we need to choose 1.7 or 1.5. For tacking fasteners or tacking boards, the spacing shall not be exceeds 32 times of the thickness of the inner plate or 300 mm, whichever is less. So this is with respect to E minimum. So maximum width distances should not exceed at any stage 12 times epsilon. So where T is thickness of the thinner outer plate. Okay, this is what the maximum edge distance. So next, if you go for one review question on the pattern of the boards. So this was the gate question. One of the gate question. The question was like this: identify the most effective butt joint. So here they given different 4 kinds of joints here. Okay, here you should identify which is the effective butt joint. Here they given the the cross sectional property here, the cross section of the joint. Okay, the plates having the same thickness. Here they have provided 3 rows of bolts here. Okay, this is what we call it as double cover butt joint. Okay, in the plan view they given here. This patterns in the plan view. Here they given the cross sectional view. Each comprising of 6 bolts with same pitch and gauge distance. So here they provided one the elevation of the the joint, double cover butt joint, and what the plan view of the joint patterns. Here we should choose which is most efficient joint, butt joint. Okay, most efficient butt joint means what? It should transfer from one end of the plate to the other end. From one end of the plate to the force, it has to transfer to the other end. Okay, that is what the most efficient section. If the joint transfers 100% fully, that is what's the most efficient joint. So here we have different patterns here. Okay, here we have different patterns. Diamond pattern is given in A, option A. So again, inverted diamond pattern is given in option B. So chain pattern is given in option C, and a staggered pitch pattern is given on option D. So which is the most efficient pattern? So most efficient the pattern here is the diamond pattern. Why? Because the reason is clear. The net area for the the section, because of the diamond pattern will be more here. So this also diamond pattern will not consider this compared to A and B. A is the most stronger joint. Why? Because at this joint junction we have 3 number of bolts. So if you want to break this cover plate or the main plate, the bolts have to break first. 3 bolts here, we have 2 bolts and 1 bolts. Whereas here, so here we have, since we have 3 bolts in the case B at here, so automatically we have less area, net area here. So the cover plate will fail. So in any joint, if any one of the joint or member fails, then it will come under what? So it's a joint failure. So when compared to these two diamond patterns, so this is having more efficient compared to this one. So chain is having this what the chain pattern. So it's also efficient, pattern. So and it will be less efficient when compared to diamond pattern, which is more efficient. So here option A is correct. So this is what with respect to the pattern of the board. So next, if you go for the capacity of the bearing type of boards, so you might have calculated the bolt value in your design of steel structures, where shear capacity of bolt is VDSP. So the design shear strength of the bolt, that is equal to VNSP by gamma MB. So gamma MB you should choose from table number 5. Okay, partiality factor for materials, where VNB is the nominal shear bearing strength of the bolt. Okay, that is equal to FU root 3 NN ANB and NS ANB. ASP. So where Fu is ultimate strength of the bolt or the material. Okay. So NN is what the if you are in the shear plane, if the shank portion is coming in the shear plane, then you should choose NS and NS in ASP, where ASP is the cross section of shank portion if you come across in the shear plane. Okay, NS is the number of planes you are getting in the in shear. Normally we will get what the single shear and double shear cases. So okay, based on that you should choose the proper NN and NS. Sometimes in the questions they will give information about the threaded portion, the plane shear portion. So when whether the thread portion is coming in the shear plane or the shank portion is coming in the shear plane. Okay, you should know that. If a thread portion is coming in the shear plane, we should choose NN value and ANB value. And shank portion coming in shear plane, then you should choose NS and ASP. NN and NS depends on number of shear planes. For example, if you take what two plates connecting here using a lap joint, okay, using what are the bolts, one bolt, here we are going to get only one plane. So therefore you can assume NN equal to 1 or NS equal to 1 for your regular problems. But whereas in gate examination, they will provide this information, whether it is NN or NS. That is, NN means what? Whether you're getting thread portion at this junction, thread portion of the bolt at this junction, or shank portion of the bolt. If you're getting shank portion of the bolt, okay, if the given information about the shank portion, then you can choose NS equal to 1 and ASP equal to pi d square by 4. Okay, pi d square by 4, where d is your nominal diameter of your bolt. Whereas, assume that for the same case, if the given threaded portion, so I have shown the ordinary bolt in the last slide where we have thread portion and shank portion. From the shank portion to make the threads, what they remove? They remove some portion of the area to make the threads. So for that we need to remove the area. The area this will becomes what? 0.78 times. So 78% of ASP we should take for A and B. So correspondingly, so if the number of planes are 2, then you should take NN equal to 2. If both the planes you are getting, threaded portion. If you're not getting threaded portion, whatever the information they will give, according to that you should take. Okay, this what with respect to design shear capacity of the boards. Okay, NN and NS you need to choose carefully. Okay, and accordingly the areas. So A and B equal to 0.78 times of ASP and ASP equal to pi d square by 4. Okay. So this is what with respect to shear capacity of the board. Actually, we have discussed that different types of failures. Okay. Where we discussed what tearing type of failure, bearing type, shear type, and black shear failure. Whereas for a bolt, we should calculate minimum shear and bearing strength. Okay, now we will go for bearing capacity of the board. Okay, so here this is another strength of the board, bearing capacity. According to the code, this is the formula: VDPB equal to VNPB by gamma MB. Again, gamma MB is the partiality factor for material, which you choose from table number 5, where VNPB equal to what? 2.5 times of KB dt FU. 2.5 times of KB dt FU. Okay. Now, what is KB? KB is what? Your list of these 4 values. That is E by 3D naught, where E is the edge distance what you have provided for the bolt pattern. Okay. Then P is the pitch you have provided. D naught is the what? The clearance hole, that is nominal diameter plus what? Nominal diameter plus the clearance of the bolt hole. Whereas FUB is the ultimate strength of the bolt. FU of the plate is FU here in the denominator. So you should calculate all these four. That is least value of KB. So sometimes in competitive examination, what they will do, they will give directly this KB value. So no need to calculate all these things. So in that case, so some may be assumed E value different way and P value and these values will different manner. Therefore, they will give KB value directly. Okay. They will give KB value directly. So therefore, we can calculate the bearing strength here. KB value will be given directly. D is diameter of the bolt. Where T is, it will vary with respect to so many connections. Okay. It will vary with respect to some connections. For example, if you go for lap joint, two plates you are connecting. Okay. Assume that bottom plate is having more thickness. Assume that 10 mm thick bottom plate. So whereas top thickness is what? Top thickness is 8 mm. Then whichever is least, we should take that value. Okay. So out of 10 and 8, whichever is least, you should take that value. That is 8 and 10. Here you should take 8. Okay. That is what the thing we need to consider here. That is, here T is will going to vary with respect to different types of connections. So we should choose lesser thickness. Okay. Now, next, what is FU? The ultimate strength of the material, that is bolt, we should consider here. So this information, FU, KB information they will give, whereas they may give the gamma MB also sometimes they will give directly. Otherwise, you should remember that value. Okay. The thing here is you should calculate the bearing strength. So how they will give here is one question I was seen in the competitive examination where they asked it like this: what is bolt value or what is strength of a bolt? Strength of a bolt or bolt value will be the least strength of what? Shear capacity and bearing capacity of the bolt. Shear capacity and bearing capacity of the bolts. Okay. So here you should remember that value, that is bolt value or the capacity of a single bolt is, you should calculate the two strength according to 10.3.3 of the class code book, VDSP and VDPB, whichever is least, that is your strength of the single bolt in the joint. Then if you move on to the eccentric connections part, so this part very, very important. So I will going to discuss today. So all the previous year GATE examination papers, what they asked from last 14 years. So with respect to the connections, that is with respect to eccentric connections here. Okay. Here if you observe, this was the question, 2-mark question, one of the previous year GATE examination question. So normally they won't ask the the regular bolts and the concentric connection part, the bolted problems. Here they given the eccentric problem here. So if you observe here, a bracket connection is made of 4 bolts. So you should mark here 4 bolts. Here they used of diameter 10 mm diameter, and it is supporting a load of 10 kilonewton. 10 kilonewton load is supporting at an eccentricity of 100 millimeter. The maximum force, okay, the maximum force to be resisted by the bolt will be, so how much? So here they are given the 4 options. Option A 5 kilonewton, option B 6.5, option C 6.8, option D 7.6, 7.16. Here this is what the problem. So I observed that so many times I think there 4 to 5 times they asked all the times the bracket connection problems. Here they will give the figure here. This is what your bracket plate. So this is what your original maybe column or a beam. So this is what your bracket plate. So load is acting over here. Your P is the 10 kilonewton load acting over here. So E is the eccentricity. So from the center of the joint. So if you consider this is the joint pattern. So from the center of the joint, they will give the eccentricity is 100 millimeter here. So then they given what? The spacing between the bolts. Okay. Here from the center, they given here 2 bolts. Okay. Here at the top from the center line, 2 bolts on the bottom line. So this the Y distance from the center line is 30 millimeter to this bolt. So you may call it as this is bolt number 1, 2, 3 bolts. There are 4 bolts here. If you observe your 1, 2, 3, 4 bolts. Where in case of bracket connection, number 3, this bolt will receive more load. Okay, this is the most load receiving bolt from this 10 kilonewton load because of eccentricity and bracket connection. So you should remember that point also. So whereas here you observe they are given 4 number of bolts, but if you take what the center line, okay, like this center line, where this is your CG, this is your CG. Okay, from the center, 30 millimeter for the first bolt is given, 30 is given for the second bolt. Whereas the what is that y distance? So with respect to y axis from the CG, they given 40 millimeter to the, so these 2 bolts and 40 millimeter to this bolts. So that means they are spaced at equal intervals. Okay, from the center. So horizontally these 2 bolts are placed 40 millimeter. Vertically these 2 are placed 30 millimeter. Okay. Now here they given all the dimensions are in millimeter. So now to solve this, so we need to follow this procedure. So if you want to draw the, I have the time, you can draw free body diagram. Since it is first problem, I'm going to explain how to draw the free body diagram and all. So you take the bracket connection, you mark the 4 bolts, what you are considering here, 4 bolts you mark here. Okay. So after marking the 4 bolts, you mark corresponding distances here, 30 millimeter and 30 millimeter, 40 millimeter and 40 millimeter. Then what you do here, you write the forces here, F1 and F2. I will tell what is F1 and F2. So you take any one of the bolt here. Okay, any one of the bolt. Okay, you can consider any one of out of these 4 bolts. Here I have considered topmost bolt, this bolt. Where what is F1? Where F1 is the force. What is F1? So for F1 is the force on the bolts due to the direct shear. So because of this eccentric load under 10 kilonewton, the bolt will going to get the 2 types of forces. The one type of force will be direct shear force. So another type of force is, that is F2. This we call it as due to twisting moment. That will going to get one more twisting moment force, that is F2. So how to mark F1 and F2 here? So this is what your center. Okay. So here you should write a radial line here from center of the bolts to their from center of bolt to the center of the joint. So that is what we call it as R1. That is what we call it as R1. Okay. So in the bolts, so first force, that is F1, you should mark in such a way that, so whatever the load direction here, so in the same direction you have to mark here, that is your F1. So that is for the force, force getting by the force F1 due to the direct shear from eccentric load, whereas F2 due to twisting moment. How we need to write to F2? So where what we have written the radial line like this, so perpendicular to this you should write F2. Okay, this is what your F2. Okay, 90 degree. Whereas F1, so assume that I will write separately here. So this is what your center of the joint. Okay, here you have considered the bolts. Okay, this is what your bolt, extreme bolt. So this bolt, you join these two using your the radial line, that is because R1. So since you are considered as in bolt number 1. So then what you should mark here is the F1, that is due to direct shear. You should mark as it is, that is if the load is downward, then you should write downward here. So F1 is downward. Now I need to mark F2. How we need to mark F2? F2 you should mark so perpendicular to your radial line, that is at a distance, at an angle of 90 degree always. So if you take for F2, this is other bolt, how we need to write F2, you should write perpendicular to this. This is what your F2. If you take any bolts here, this is what F2. F1 will be vertically downward only. Here also F1 will be vertical downward only. Here also F1 will be vertical downward. If you take this bolt also vertically downward, whereas F1 will be like this, perpendicular to your radial line. So that is what your F2. Okay. Then then the theta here is the angle between the horizontal line, what you're considering at the center of the joint, and with your radial line. That is what your theta. So this theta is equal to what? The theta between F1 and F2. Okay, here what we need here is F1 and F2. F1 and F2 is acting on this point. Okay, this is like a forces of concurrent force system. I want resultant of that force. Okay, so that is what the question they asked in the problem. So what is the resultant force or the maximum force which is received by the single bolt? So okay, that is the resultant force equal to, since it is F1 and F2 acting at the same point, that is on the same board, it will come under concurrent force system. Okay, therefore we should apply the formula. What is the formula for concurrent forces? If you want resultant force, you should take square root of F1 square plus F2 square plus 2 F1 F2 cos theta. Where what is theta? How to calculate theta? Theta is the what? The angle between the radial line and your horizontal line. Okay, so if you go to the solution here, so no need to write all these things in the exam. Directly you can calculate F1, F2 and resultant, direct theta and resultant force. That is what we need to do in the exam. So if you observe the the solution here, what is F1? F1 is the force getting by the bolt. So acted upon by the bolt due to direct shear, force on bolt due to twisting moment. Okay. So now that what is F1? F1 is equal to P by 4. So what is P? So P is the eccentric load which is acting on the bracket connection. What is P is acting on the bracket connection here? 10 kilonewton is you take 10 kilonewton here. But denominator is 4. So 4 is nothing but number of bolts which is given in the joint. So in our problem, they given 4 number of bolts. Therefore, you should take P by 4. If they given 6 numbers like this, so assume that if they given 6 numbers, 3 on this side, okay, 3 on this side. If you have bracket connection like this, okay, then you should take how much? 6 bolts. That is P by 6 you should take. So this is what you need to do. So then this if F2 is what the formula here is, F2 equal to PE into R1 by sigma RA square. Nothing but M is nothing but moment due to the load, eccentric load, into R1 is the radial distance what we marked already. This distance here also marked. So divided by sigma Ri square. So I will tell how to calculate the what is that P, E and R1. So P is directly you can take directly the eccentric load 10 kilonewton. Okay, whereas E, what is E? Your eccentricity 100 millimeter, and R1. What is R1? The radial distance. So how to calculate the radial distance? So if you take the radial distance here, this is what your bolt. You draw. If you draw the triangle here, so what is the side? This side is equal to 30 millimeter. Okay, whereas the adjacent side of the triangle is 40 millimeters given. So from this you calculate R1. What is R1? Square root of here written here 30 square plus 40 is going to get 50 millimeter. So this is for what? This bolt. So if you calculate for this bolt also, that's also same. For radial distance here, how much is that? So square root of 40 square plus 30 square. Again, if you want for this bolt, again R is same. For this bolt also R is same. Here, since the bolts are spaced at equal intervals, so same interval the spacing. So the R1 distance, this distance for all the bolts is same. R1, R1, R1 for all the bolts is same. Okay, this is what your R1. 30 square plus 40 square equal to 50 millimeter. So next R1 you calculated, P is known 10 kilonewton, E is 10 millimeter eccentricity. So distance also given in millimeter. So don't worry, E is also taken in millimeter. Okay, and then divided by sigma R square. How to calculate sigma R square? Sigma R square is nothing but you should calculate R for all the bolts. So since we know that if you calculate all the bolts, R we are getting same. Therefore, if you can take in one, if you consider first bolt, second bolt, third bolt, or fourth bolt, for all the bolts, R is same. Therefore, you can directly take it as sigma R square equal to what? What is sigma R square? Sigma R is whole square. You can directly take it as 4 times of R square, where R is constant for all the members, are the bolts. What is R? 50. If you take 50 square, you're going to get 2500. They have substituted directly here 2500. What is 2500? Is nothing but RA square for one bolt. Since we have 4 bolts with the same R, I will multiply in the denominator with 4. Okay. So as of now, we calculated F2. F1 is 2.5 kilonewton. F2 is this value. So here F2 is what? P is 10 kilonewton. E is 100 millimeter eccentricity. 50 what your R1? How to calculate R1? square root of x square plus y square. So then divided by sigma r square. We have 4 number of bolts. You calculate, you take the value of r square here, that is 2500. You will going to get 5 kilonewton. So then, since as of now we know what is F1 and F2. Okay. Now if you go again, you go for tan theta here. So in this figure, if you go for tan theta, what is tan theta? Opposite by adjacent side, that is 30 millimeter. Opposite side in this theta 30 millimeter, whereas adjacent side is 40 millimeter. So 35 40, you will going to get theta as 37 degree. So since it is come under coplanar concurrent force system, so you can apply the formula, resultant force formula, r square equal to f1 square plus f2 square equal to f1 f2 cos theta. Otherwise, if you want r, resultant force, square root of f1 square plus f2 square plus 2 f1 f2 cos theta. So here if you substitute f1 equal to 2.5, what we got here, that is p by n. P is the eccentric load, n is the number of bolts, 2.5 kilonewton, where phi is the F2 due to the moment calculated using this formula, that is 5 kilonewton, 5 square, plus 2 into 2.5 into 5 into cos 37 degree, you're going to get 7.16 kilonewton. So for this problem, the resultant force for the extreme bolt air is the fourth option, option D, 7.16 kilonewton. So actually this question is repeating from last. They asked to, if you observe the question paper, previous year question paper, they asked 5 times. The different pattern of bolts they will give, but the concept here is same. Okay, where you should calculate F1 due to shear, F2 due to moment, and your theta, and lastly you should calculate the resultant force. Okay, shall we move on to next problem now? If you see here, the next problem, this is a 2 marks get previous year question paper problem. Here they given the distances in some other way. The same problem they given some other way, but here they mention that what is the problem we will see first. A column A is subjected to the load through the bracket as shown in figure. This is what the bracket, this is what your column. The resultant force in kilonewton up to 1 decimal place. Up to 1 decimal place in the bolt 1 is. Fill in the blanks. Here they not given any option for us. So these questions we call it as numerical answer type questions. So you should type in the after calculating using the virtual calculator, you should type as 6.6 kilonewton, not as a 6.0 also. Okay, you should nearest to the first decimal, we should type the answer here. Where these questions we call it as numerical answer type questions. So nowadays they are going to ask these type of questions in case of steel structures. You should know how to calculate that. This is exactly similar to previous problem, but they're asking us what at this bolt, that is at this bolt you should calculate what is the maximum, what the resultant force. This is exactly similar to previous problem. You calculate F1 first, then calculate F2, then calculate theta, then calculate what your F1. Then if you go for the solution here, as usual, what you need to do, you draw a radial line from center. Here I will show now, radial line from center. Okay, this R is 5 millimeter. How it is 5 millimeter? So if you draw a radial line here, okay, here this distance is, since it is 10, this also 10. So since center is exactly the center, these two lines are meeting at 90 degree. Therefore, you're going to get all R as equal. That is equal to 5 meter. Here R equal to 5 meter for all the bolts. Okay, whereas in the last problem also R was constant. Okay, then what is we need to do here is you write F1 and F2. So how to write F1 I have told clearly. So if it is P is acting vertically downward, you should write vertically downward here, F1. So what is F2? F2 is the load due to the moment. How we should write F2? I have told in the last problem, you should write perpendicular to this. So this is what your radial line. This is what your radial line. Perpendicular to this, you should write F2. Okay. So then angle, what is the angle between these two? 90 plus extra. What is that extra? 90 plus 45 degree. That is 135 degree. No need to calculate here. You can calculate manually. No need to apply tan theta and all. So the angle between what? This F2 and F1. How much it is? You can clearly see here. This is 90 degree plus 90 by 2. This is actually 90 degree, or 180. This is also 90 degree. 90 by 2 is 45. This, what is the angle between F1 and F2 here is 135 degree. So as of now, we know what is R value. R is 5 millimeter. And also, what is that? Theta here is 135 degree. Okay. Now we can go for calculation of F1. What is F1 formula? P by N. P is the eccentric load divided by number of bolts what we have provided. So in our case, P is 10 kilonewton. Number of bolts provided here is 1, 2, 3, 4 number of bolts. You should take all the bolts here. 10 by 4 we are going to get 2.5 kilonewton again. So if you go for F2, what is F2? F2 formula is moment into R1, nothing but P into R1. P into R1 divided by sigma R square. What is P here? 10 kilonewton. What is E eccentricity? Here they given 15 centimeter. Okay. What about this R square? R is constant here. That is R is 5 millimeter. How many bolts are there here? For all the bolts, R is constant. Therefore, in the denominator, the summation I will take all the 4 bolts into 5 square. So if substitute P, E and R1 for 1 bolt and sigma R square in the denominator, if you substitute and calculate, you will going to get 7.5 kilonewton. So then you go for what? Your resultant force calculation, similar to previous problem. So resultant force equal to F1 square plus F2 square plus 2 F1 F2 cos theta. Your cos theta we have calculated directly from the figure. R also we not calculated, we have taken directly from the figure since the meeting line they are given at 90 degree. So if you substitute here, F1 2.5 square, F2 7.5 square, and 2 F1 F2 cos 135 degree, you are going to get 6 kilonewton. Here you should type in the exam 6 kilonewton. Okay, so this is what the questions we correct as numerical answer type questions. So this is exactly similar to the previous problem. This is also one of the previous year GATE examination problem. So if you go for next problem, if you see again the question is repeating, only the data is changed here. Okay, here they given what the problem like this. 4 bolts P, Q, R and S of equal diameter are used for bracket subjected to the load 130 kilonewton as shown in figure. So here they given clearly given the center line here when compared to last problem. So center line is given. So 200 millimeter eccentricity also given. Okay, then the 240 millimeter is the distance between the the bolts is given between the RQ and PS. Here they given the from the center line 100 millimeter distance between the R and S bolts. So now if you see from this figure, what you can see here, what is the distance here? You can, if you take the center here, since it is symmetric, the CG will become under center point only. Okay. Now what is this value? This value is 245 by 120. Okay, from the center line to the bolt top bolts, it may be for P bolts or Q. If you come to bottom bolt R and S, then also you're going to get 120. The distance from the CG, the Y distance. If you go for what the horizontal distances from the Y axis from the CG, so 100 by 2 and 100 by 2, that is 50 millimeter and 50 millimeter. Okay, this is for the distance you should know. Whereas in the last problem they given directly 30 and 40 directly they given. In the last previous one also they given 10 mm directly. Here you should know how to see the distances with respect to center point of the joint to all the bolts. X and Y distances you should know. Okay, then X and Y distance you should know. Then here if you go for calculation of F1, so here on which bolt they are asking here, the bolts force in P they are asking here. Okay, the force in the bolt P they are asking here. So where is P bolt? This was the bolt. So this is exactly similar to the first problem what we taken into discussion, this eccentric connection. P bolt, here for P bolts you should draw what F1 you drawn here, F2 perpendicular to this radial line. Theta you should calculate here. So theta is equal to, so again you should apply the formula. What is that formula? Square tan theta cos theta equal to 150 by 130. Okay, 1 second please. So here you can go for theta here, the distance between these two. If you calculate theta here, how are you going to calculate theta? This distance. So 240 by 2, 120. So that is what your opposite side. Adjacent side here is how much? 50. This is not 130, this is actually 120. Okay, 120, correct. So now you calculate theta for that. So then you go for calculation of F1 and F2. Here F1 is P by A. Number of bolts here also they have put only 4 numbers. 130 kilonewtons is the external load acting here. So F1 is 32.5. If you go for F2, you P into E into sigma r square into RP. RP you have calculated here. How to calculate RP? The radial lane distance. So this height is what? How much? This height is 120 and this is what 50. So where r equal to square root of 50 square plus 120 square. That is what your r for your bolt P. So that is equal to 130 millimeter. The same r will be there for all the members, all the bolts. So therefore you can take RP, RQ, RR and RS equal to 130 millimeter. Okay. Now you go for F2 substitution here. So at bottom you should substitute sigma into r square. Here r is 130, therefore you substitute r here. So you take it as r square here, 130 square. And 4 is the number of bolts, sigma. So here in the numerator, P into E, P is 130 kilonewton, where E is 200 millimeter. So eccentricity, where the R1 here is 130. If you calculate that, you will go to 50 kilonewton. You substitute all the things to the formula. Okay, you will going to get how much? The 69.33 is the answer. That is option number B is the answer. Okay, for our problem. So this is what the last, almost from the bolted connection, they are asking the same type of question. If you observe question number 1, okay, this is what the question number 1 what we discussed in detail, and this was the solution. Question number 2, the same bracket connection, but they are given distances in some other way, but the procedure is same. We should calculate F1, F2 and theta. If you go for what your next problem, then they given the same thing, but we should they given some specified board. For that board you should calculate the what is supposed to calculate. For that board you should supposed to calculate the resultant force. So if you observe for next exam also, you can you should be familiar with these type of questions for upcoming GATE exam, since they're asking commonly it's the same type of problem, calculation of resultant of force. So this is what the problems with they're given in the GATE examination till date. So next we move on to welded connections. So normally welded connections will give for to connect different types of steel elements. It may be plates or the plates we will go for butt joint, slot joint. Here in field normally we will provide 95%. 95% will provide what? The fillet weld. So on groove weld, around 95% we will going to use this called butt weld. So in case of butt weld, we will keep one material adjacent to other, whereas in case of fillet, we will keep one material above the other. So we can go for directly with the weld. So this is what the first figure shows what your groove weld, where this what we keep two plates one adjacent to other. So this is what your what is this? The fillet weld. Here we have placed one plate above the other plate, and we are given the welding here. This is what a fillet weld. Okay, in fillet weld, okay, you need to remember the technical terms here: thread thickness, okay, and also the size of the weld. So normally 95%. So in our construction, we will go for fillet and groove weld. In some other special cases, we will go for plug, slot, and spot welds. Okay, now if you move on to the next, the specifications according to the code for welds. So what we discussed in the bolts, similarly we should discuss for welds also. So first, size of the weld. So what is the size of the weld? So size of the fillet weld. So according to the code, that should not be less than 3 millimeter. Okay, so this is given in table number 21 in detail here. So this is based on what? The table number 21 of IS 800-2007. So these things you should remember. Okay, so this the value like this 3, 4, 6, 8. The range of the plate you are connecting. If you're connecting up to 10 mm thick plate, you can go for minimum 3 mm size of the weld. If you go for 22, 32 mm the bolt, then you go for 6 mm size of the minimum size. This is what minimum size. Okay. So if you go for, the butt weld, this is what with respect to fillet weld we discussed. If you go for butt weld, the what is the size you should give here equal to the effective throat thickness. So effective throat thickness is whatever you're getting, that's that much of size you should give for butt size. Whereas in case of fillet weld, you should give minimum 3 mm, or you should go by the table number 21, based on thickness of what? Thickness of thicker part of the plate. You can choose any one value. Okay, based on the thickness of the thicker plate. This things on this table you should remember to some extent. Okay, they may ask this question. So 3 mm is you should remember, and also for butt weld you should give effective throat thickness size. Okay, so next is the effective length of the weld. The effective length of the weld in practice, we will give, okay, drawing, whatever the drawing you have written on the paper, plus 2 times of the weld size. And at the same time, this size will not be less than 4 times of the size of the weld. So wherever if you draw the weld on any element, so if you draw the weld, how much the effective length, total length we should give? The total length will be equal to 2 times what we shown in the drawing. So no, what is the drawing length shown in the drawing plus 2 times extra we should provide. Okay, to that we correct as end returns we should provide at both the ends. That is what the word said, that at the same time this total length should not be what? Less than 4 times of size of the weld. This is what your effective length of the weld in case of fillet weld. In case of butt weld, it can be taken as the continuous full size of the weld, and in the same time it should not be less than 4 times size of the weld. So this one they asked in the some of the examinations, IAS examination, I observed this question. So what is the effective length of the weld? So effective length of the weld equal to the actual length of the weld, what is shown in the drawing, or the actual length of the weld plus 2s, where s is the size of the weld, 2 times of the s which we need to provide extra. Okay, this is what you with respect to specification of bolted connection. If you go for effective throat thickness, so in some specification of the board, they mention that effective throat thickness. So what do you mean by effective throat thickness? That shall be taken as k times of the fillet size. So what is effective throat thickness? So this is T is the thickness. If it take as a E, the effective throat thickness, that is equal to K into S. Where what is K? K is the constant for, if we should need to take for different fusion phases of the angle, we need to, it will vary according to the code, table number 22. You should remember to some extent this table. So where for a angle between the faces, for example, if you're connecting two members like this, one member is this one, at the bottom you're connecting another member, these two members are meeting at 90 degree here. Okay, these two members are meeting at 90 degree here. Therefore, angle between the fusion faces is what? It will come under 90 degree. Therefore, K value is 0.70. K value is what? 0.70. Okay. Whereas if the angle fusion faces is, assume that you the inclined one, then the angle will be more. So whatever the angle, you should know the K value. So on which the K value varies with respect to the angles. You should remember this table. Okay. What is throat thickness? Throat thickness equal to K into S, where K is the constant we should take from the table number 22, and you should remember this table also, where S is the fillet size of the weld. So we will see one review question on this. So this was a 2011 GATE question. The question goes like this: for the fillet weld of size S shown in the adjoining figure, the effective throat thickness is, that is K into S equal to how much? So here, whether it is 0.61 S or 0.65 S, okay, 0.65 S or 0.70 S or 0.75 S. Here you see here, the angle between the fusion phase here is 99 degree. Angle between the fusion phase here is 99 degree. Therefore, what you can do, what is the value you should choose here from the table 22. So you should know this value. You see here, 91 to 100 degree. What is the value you should choose? The K value you should choose 0.65. So that's why you should remember to some extent this table. So they have asked directly 1 mark question on this effective throat thickness. So The K value depends on again the angle between the fusion faces, which is what given in the table number 22 of IS 800 2007. Okay. Next here is you go for what how to provide the length size of the bed for different edges. Okay. How to provide the size here is you see here. So if both the ends are meeting at the at 90 degree, the plates meeting at 90 degree, then you should provide what is the maximum size of the bed you can provide. Actually, we are seeing from the table number 21 how to provide minimum size of the bed, that is 3 millimeter minimum, and again it depends on the thickness of the plates what you are connecting. Whereas in case of the how to decide the maximum size of the bed, that is with respect to the shape or the edges what you are connecting. Assume that you are connecting square edge here like this, square edge here. What is the maximum size of the bed you can provide here? Okay, that is equal to the maximum size equal to whatever the maximum thickness of the plate minus 1.5 mm. If the sharp edge is meeting here, then you should provide how much? The size of the plate minus 1.5 millimeter. Okay, that is your maximum size of bed. You should not exceed like this. So yeah, this is not acceptable like this, and also for the top plate should not exceed here. Okay, the maximum size will be how much? The size of the plate minus 1.5. Okay, whereas this for sharp edge. If you go for curved edges, for example, when you're going to receive this type of thing, when you're connecting the plate, sharp edge plate when you're connecting, when you're going to get this type of things here. Whereas in case of you're connecting angle, assume that you're connecting angle sections. So angle sections will have curve shape at the ends. For example, if this is what your angle, you can't see directly, properly here, we're going to read separately. So this is what your curved edge, you're connecting to some other member. So when you're connecting the ear, so at this junction, okay, when you're connecting here, so then what you should do, how much you should give the maximum thickness? The maximum thickness or the size of the weld equal to 3/4 of the thickness of the plate. Or in thickness of the plate, you should deduct 1/4 of the T. Here is given. You should remember these two values. These are the very important values are here. So when you are connecting sharp edges, then maximum size will be equal to the thickness of the what? The thickness of the plate minus 1.5 millimeter. If you're connecting rounded edges, then the maximum size will be 3/4 of the thickness or thickness minus 1/4 of the T. So that is what the size, maximum size of the fillet welds. So then if you go for strength of the welds, then if you go for strength of the welds, according to the code, what we discussed in the in the case of bolted connections, the bearing strength of the bolt and the shear strength of the bolt. Here in case of fillet welds, this is what the formula. FWD design strength of the weld equal to FWN by gamma MW. So again, what is gamma MW? The partial safety factor you should choose from table number 5 of the code book. Okay, this since it is welded connection, you should choose carefully whether it's shop weld or field weld. Okay, in the similar way, if you go for fillet weld, in WN, what is WN? Nominal what? The Fu by root 3 is the strength of the nominal shear strength of the weld, Fu by root 3, where Fu is the ultimate strength in the weld or the parent metal. So that is smaller of the ultimate strength. If you're connecting a plate, so if the plate grade is less than the weld grade, weld is also metal, less than the weld grade, then you need to choose smaller of those two values. Okay, out of parent metal and weld metal. So that is what your Fu. Root 3 is constant. Gamma and we should choose from table number 5. Then if you apply this, what you're going to get? We're going to get the design strength of the fillet weld. Okay, based on its throat thickness area. So in the similar way, so this is what when the one load, the load is acting concentrically. So when only axial force is acting like that, when you are getting what the normal and shear stresses on the fillet welds, then how to calculate the equivalent stress? So equivalent stress equal to, according to the code, square root of Fa square plus 3Q square. This value equivalent stress must be less than always this value, Fu root 3 gamma MW. That is design strength of the weld. Okay, where Fa in this formula, where Fa is normal stress. Okay, it may be under compression due to compression or tension, axial force, or where Q is the shear stress. Okay, maybe due to shear force or tension. So Q is the shear force. Shear stress arises due to tension or shear force, whereas F is normal stress arises due to compression or tension due to axial force. Okay, normal stress. So these formulas, these two formulas, you need to remember to solve, some of the welded connection problems related to gate examination. Okay, so I will discuss one problem now today. So after that, I will stop. Okay, then here I will read the question here. This also I have one 2 mark question. Two plates are lap jointed in a workshop. You see here. You should know they have mentioned here they are fabricated in workshop using 6 mm thick fillet weld as shown in figure. The figure is not drawn to scale. Don't worry. The ultimate strength of the weld here is 410 MPa. So here figure is given. This is what the plate. They are connected to another one plate. The width of the plate here is 120 millimeter. Here the weld length they have projected on the plate here is 200 millimeter. Okay. Here this is what the original the gusset plate. This is what the plate. Steel plate. This is also one plate. This is also another plate. They have connected each other. So one plate is overlapping on another plate by providing 200 millimeter weld here. Again 200 millimeter weld here. Okay, here also they have provided the entire width, they have provided 120 mm weld. So this is all what called as fillet weld. So now what you need to calculate here is as per limit state of design IS 18207, the design capacity in term kilonewton rounded up to the 3 decimal places in welded connection is. This also numerical type question. So here we need to calculate individually the load. So the design capacity of welded connection, we have here a formula P equal to what FBD into the length into throat thickness, nothing but we have the general formula for stress. What is stress? Stress equal to load by area. Okay. So here what I want here is I need what is that they are asking design capacity. I want load. If you want load, you multiply stress with area of the weld. So what is stress in the weld? FB is the stress in the weld. What is area of the weld? L into throat thickness you should take always. So what is this? Length into thickness you should take as the area of the weld, where FB is the stress in the material. So P is the load carrying capacity. The same formula, load equal to stress into area. Now what is stress? So stress in the material, we have seen the last formula. What is stress in the strength of the weld? Always the Fu of the weld or the parent metal Fu of the metal √3 gamma mw. We have seen the last formula according to the code 10.33, where gamma mw here is they are not given anything. Therefore, you should remember partial safety factor. The value gamma mw is 1.25 for shop fabrication. So that is what your stress portion. They have written their stress portion. The length, effective length of the weld is you should add all the overall length of the weld. So bottom 200 millimeter they have provided. So you should measure from here 200 millimeter, 200 millimeter, 120 millimeter. Total how much? 520 millimeter. Total length of the weld you have provided for the connection. Okay. Next here is the 0.7. What is 0.7? 0.7 here is what? The K value, K into S. Since the two angles are meeting at 90 degree, what is the K value? 0.7 for 60 to 90 degree from table number 22. What is K value? K value is 0.7. So into 6. What is 6? The thickness of the plate. So here they are connecting two plates of the same thickness. Therefore, T is 6 millimeter. So if you substitute all things to the formula, you're going to get what is the answer here is 1 second. Answer here is you're going to get 430 kilonewton. So this is what the strength of the fillet weld in this corresponding joint. So if you observe this formula, they are not given any information with respect to partial safety factor. You should remember gamma mw values, and also you should remember the formula. A simple formula. This is not in the this is not there in the code book. So stress equal to load by area. Load equal to stress into area, where stress is strength of the weld. That is stress in the weld. That is equal to Fu √3 gamma mw. Where L effective is length, area equal to length into thickness, where length is what total length of the weld what we have provided, where thickness is throat thickness. Throat thickness is what is the formula for throat thickness? K into S. rod thickness here is what K into S, where K is 0.7. You should remember that value also here. So at least you should remember for this type of connection, 90-degree connection, the K value is always 90 degrees, so 0.7 from table number 22 into thickness of the plate. If you calculate that, you're getting 413.586 Newton, nothing but 413 kilonewton. So friends, in next session, I will going to continue some of the important problems on bracket connections of the welded connections part, and we'll discuss plastic analysis and remaining topics with respect to GATE 2021. Thank you very much.
Thank you, Rajeeth sir, for enlightening your knowledge on steel structure related to GATE 2020. I thank all the participants for patiently listening. Thank you all.